Okay, so moving on. All right, so we also have, in this next slide, we have charges create electric fields. Okay, so charges create these electric fields, and so I've got this electric field of a point charge. So I've got this charge, and notice the electric field is coming out in equal directions, and it gets, notice the vector quantity of it gets smaller as it leaves the charge. So the further away I get, the weaker the electric field gets. So E equals KQ over R squared here. And so the actual formula is this. So we've got two formulas for the electric field now. We've got E, well, we just have one. E is equal to KQ over R squared. And then the force that it feels, so I've got a positive charge here. It's got electric field lines going out in equal directions. Okay. Say this is Q1. And let's say Q2 equals 2Q1. How would you draw that? What would it look like? You're right. It would look like this. Four, 5, 6, 7, 8. This one has 4 field lines. This one has 2 because it's got twice as many. Much stronger electric field here. And again, it's the over R squared. Okay, that's the electric field. So you know, so your 3 equations so far are Q is equal to the number of protons or electrons, plus or minus. That's the charge. You know, Coulomb's law is equal to K times Q1 over Q2 divided by R squared. All right, where we just find the magnitude, and this is of course a scalar and this is a vector, but we find the magnitude and then we decide which direction it's going based on where the charges are and what the charges are. Where we learn that K was equal to 9.00 times 10 to the positive 9 newtons meters squared per coulomb squared. Okay, and then we've got the electric field, and the units for this is newtons. I noticed today on the quizzes we didn't put down units a lot of times. So is equal to KQ over R squared. And again, we'll look at the picture and decide what the electric field is. All right. We'll look at the picture and decide which direction the electric field is going. All right. Now, here's the other thing. The units for this is newtons per coulomb. Well, where the heck did that come from? From this. E also equals the Coulomb's force divided by Q. All right? So that's the big idea on electric fields. Let's see if there's any more that they got to tell us. Probably. Okay. All right. For multiple charges, the electric field is found by using the superposition principle. In other words, you find out at this point here, you figure out what the magnitude of the electric field is by this one. You figure out, still using this point, find out what the electric field is on this one. Notice I forgot to tell you something. Look at this. So let's say we've got this. Positive Q is equal to this. This is Q1. Let's say Q2 is equal to negative 2Q1. Oh, it's a negative charge. Aha. So here's what its field lines, it would be going like this. There's 8 of them. I didn't draw that very well. There's 8 of them, and there's my negative charge. The electric field lines go towards a negative charge, and the electric field is emanated out from a positive charge. So these guys are out looking for each other. Let's look at the properties of the electric field in the next video.